We have another example. Again, we have a rational function. Look always at the denominator. If you are going to replace x by 0, you will have 4 minus 0. Square root of 4 is equal to 2 minus 2 gives me 0 in the denominator. We do not want to have 0 in the denominator. We have to do some simplification. What we can do, we can multiply, and I'm supposed to say we're supposed to multiply numerator and denominator of my function by the conjugate of the denominator. And take a look at what we are going to have. 2 plus square root of 4 minus 5x. And in the numerator I'm going to have 2 plus square root of 4 minus 5x. We put the parentheses. Now I'm going to multiply the numerator by numerator. I have limit x goes to 0, and I have x times 2 plus square root of 4 minus 5x. This is my numerator. And if you are going to look at the denominator, in the denominator I have nothing else, just the difference of two squares. Keep in mind the formula for the difference of two squares says a square minus b square is equal a minus b, a plus b. So this is my a, this is my b, this is my a, and this is my b. So instead of having two long terms, I can simply write this as 2 to the second power minus square root of 4 minus 5x to the second power. I'm doing everything step by step. And let's take a look what we are going to have. I have limit x is approaching 0, and I have x 2 plus square root 4 minus 5x, and in the denominator I'm going to have 4 because 2 to the second power is 4. Square root raised to the second power is going to be eliminated, and I'm going to have minus, open parenthesis, 4 minus 5x. And I'm going to have again limit x is approaching 0. I have x 2 plus square root 4 minus 5x over, take off the parentheses, you have 4 minus 4, negative times positive gives me negative, negative times negative gives me positive, plus 5x. 4 minus 4 gives me 0. Let me do step by step. As I said, limit x is approaching 0. I have x 2 plus square root 4 minus 5x over 5x, because 4 minus 4 is 0. X and x will cancel out. And what I have right now, I have nothing else, just the limit x goes to 0, and I have 2 plus square root of 4 minus 5x over 5. Again, we have a rational function, but this time my denominator is never going to be 0. That's why I can simply replace this x by 0 and find the limit of this function. I'm going to have 2 plus square root 4 minus 5 times 0 over 5. I have 2 plus 5 times 0 is 0, square root of 4 over 5. I have 2 plus square root of 4 is 2 over 5. 2 plus 2 is 4 over 5. This is the solution to my problem. Let's take a look at this example. We have again the limit of the rational function, and like always we have to look at the denominator. In the denominator we have just x. X is approaching 0. If you are going to replace this x by 0, you will have 0 in the denominator. We do not want to have 0 in the denominator. So we have to find a way to reduce this function in order to eliminate x from the denominator. How am I supposed to approach this problem? This problem is a little bit complex because I have cube root in the numerator. I'm going to forget for a moment about the limit, and I'm going to copy down this function on the side. I have cube root of 1 plus ax minus 1 over x. I'm going to use t, the variable, temporary variable, which is going to help me to solve this problem. I'm going to assume that t is equal cube root of my 1 plus ax. I can rewrite this function as t minus 1 over x. Please notice that I can apply to my problem the difference of cubes, because difference of cube would have t minus 1. The difference of cube formula says a cube minus b cube is equal a minus b, and I have a square plus ab plus b square. If you are going to write the same formula in terms of t and 1, you will have something like this. T cube minus 1 cube is equal t minus 1 times t square plus t plus 1. Because my b is 1, so t times 1 is t, and b is 1 raised to the second power is equal 1. So what I'm going to do, I'm going to rewrite this function as t minus 1 times t squared plus t plus 1 over x, and I have t squared plus t plus 1. Why I can do so? Because if you are going to just forget for a moment about the original expression and just look at the second part of it, you will see that we have quotient of exactly the same terms. So if you are going to divide the top by bottom, but remember, forget about this one, you will get 1. So this part is not going to change the value of my original expression. That's why I can use it. Next, what I'm going to do, I'm going to simply rewrite this expression and write this as a t to the third minus 1 to the third over x, and I have t squared plus t plus 1. Why I did this? Because this expression is nothing else, just this formula. This is equal to this. That's why I made a long story short by writing t cubed minus 1 cubed. Denominator will stay the same. Now I'm going to replace the t by the original expression, which was cube root of 1 plus ax to the third power minus 1, because 1 to the third is 1, over, and I have x. Inside of the parentheses, I'm going to have cube root of 1 plus ax to the second power plus cube root of 1 plus ax, and I have plus 1. Cube root and cube, they are going to cancel out, and we will end up with 1 plus ax minus 1 over the denominator. I have x, and in parentheses I have cube root of 1 plus ax to the second power plus cube root of 1 plus ax plus 1. 1 minus 1 is going to give me 0. So these two ones are going to subtract from each other. And please notice that we are going to stay with ax, and I have x also in the denominator. So these two x's are going to cancel out. As you can see, I eliminated this uncomfortable for us x. Now I can rewrite this example as a limit with x approaching to 0, and I have in the numerator this time a over cube root of 1 plus ax to the second power plus cube root of 1 plus ax plus 1. Now we can replace x's by 0 and take a look what we are going to have. A over, I have cube root of 1 plus a times 0 to the second power plus cube root of 1 plus a times 0 plus 1. I have a over a times 0 is 0. 0 plus 1 gives me 1. Cube root of 1 is 1. 1 raised to the second power is equal 1 plus. a times 0 is 0. 0 plus 1 is 1. Cube root of 1 is 1 plus 1. 1 plus 1 plus 1 is equal to 3. My answer is a over 3. And this is the final solution to my problem.